Alright, in this video we're going to go ahead and continue the Unit 2 review, looking at questions 8 and 9, which are word problems. Let's go ahead and start with 8. It says, suppose 28 members of your class went on a rafting trip. Class members could either rent canoes for $16 each or kayaks for $19 each. The class spent a total of $469. So we're going to go ahead and write a system of equations and answer the question, how many people rented canoes and how many people rented kayaks? Now this question is important because the very first thing I need to do when writing an equation is determine what my variables are based on what they mean. So I need to find the number of people who rented canoes and the number of people who rented kayaks. So the number of people in canoes and the number of people in kayaks. Now to solve for these, I'm going to give them both variables. So the number of people in canoes, we'll go ahead and call that the letter C for canoes. Number of people in kayaks, we'll call that the letter K for kayaks. Now I know what my variables are. Now that we've got our variables, we have to write a system of equations. So we're going to have to write two formulas expressing something about these variables. The first equation I want to write is the one with the simplest information. So if C stands for the number of people in canoes and K stands for the number of people in kayaks, I'm going to write an equation about the number of people because my word problem has told me something specific about the number. It's told me the total number of people in my class. So if I take the number of people in canoes and add the number of people in kayaks, it should give me the total number of people on the trip. And there we have our first equation, the simplest equation, just about my variables in of themselves. Now this word problem is not just about the number of people, it's also about the money that we are spending. So I'm not just looking for the total members, I'm looking for the total money. So let's write an equation about money. We're going to have to relate each variable, canoes and kayaks, to money. So here I see I can rent a canoe for $16. So $16 per canoe. So that's relating the canoes to money. Let's find the same thing for kayaks. It looks like kayaks are $19 each, so $19 per number of people in kayaks. Now if I take a look at the total amount of money spent, $469, I get that by adding up how much I spent on the canoes and kayaks, which I've just calculated in this formula, and we have our second equation for our system, and it's about money. Now that we have our two formulas, we can go ahead and solve it for the number of people in each, which is question B. So I'm going to have to use this system of equations in order to solve. And I can use any method that I would like to solve this system. I can use substitution or elimination. What I notice that my variables up here in my top equation are almost alone. So I'm going to go ahead and use substitution for this problem. You can also do it with elimination and get the same answer. So using substitution, I'm going to take my top equation and I'm going to go ahead and solve it for C just because I feel like it. I could solve for either one. It doesn't make a difference. So let's take my C plus K equals 28 and let's solve for C. We have to subtract K from both sides. So C is negative K plus 28. Now that I have C alone, I'm going to go ahead and substitute C in everywhere I see the letter C in my other equation. Right there. So I'm going to have 16 times C plus 19K is 469. And I'm going to plug in the C value I just found, which is negative K plus 28. Let's see what we get when we start simplifying this to solve for K. I can do 16 times negative K, which is negative 16K, and 16 times 28, which is 448. And then bring down the 19K and the 469. Now let's combine our like terms. I have negative 16K and positive 19K. That tells me I have 3K remaining on the left, plus 448 equals 469. And when I subtract the 448 from both sides, it tells me that 3K is 21. And I can solve this for K by dividing both sides by 3. That tells me that K is 7. So I have just determined that 7 people rented kayaks. Now all I have to do is plug this number back into my any of my original functions to figure out how many people rented canoes. Now I'm going to go ahead and choose the top equation to plug this back into because it's a very easy equation. C plus K is 28. So C plus K is 28. And I know that K is the number 7. So if I solve this guy for C, all I have to do is subtract that K from both sides, and C is the number 21, which tells me 21 people rented canoes, and I have solved my system. Rented canoes. There we go. Let's go ahead and take a look at the second word problem. It's going to work very similarly. So each morning you do a combination of aerobics, which burns 12 calories a minute, and stretching, which burns 4 calories a minute. Your goal is to burn 416 calories, very specific, in a 60-minute workout. So again, we have to write a system of equations based on our question, and our question says, how long should you spend on each type of exercise? So we have the time that we're trying to solve for each exercise. So the time on aerobics and the time on stretching. So we have to give these variables letters so we can write equations about them. So let's go ahead and call aerobics the letter A and stretching the letter S. Now, these are the things we're trying to solve for. Let's write the most basic equation we can with them. Both of these letters represent time, so let's write an equation about time. If I have the time on aerobics and the time on stretching and I combine them, I should get the total time that I'm working out, which in my problem tells me is the number 60. There's my most basic equation. Now, my problem's not just about minutes, it's also about calories. So I have to tie each of these variables to how many calories I burn doing them. So depending on how long I spend on aerobics, I burn 12 calories per minute on aerobics. So 12A. For stretching, each minute I spend stretching burns 4 calories. So 4S. And if I combine those two totals for calories, I should get the total calories for my workout, which is 416 calories. Now that we have our system of equations, we can go ahead and solve for question B. How long should I spend on each type? Again, I can solve this system with any method that I choose. I could use substitution again. Just for fun, let's go ahead and use elimination instead. I can see that it would be pretty simple to make my A's or my S's match in coefficient number. I'm going to go ahead and make my S's match because multiplying by 4 gives me some smaller values than multiplying by 12. So I'm going to go ahead and write my equations down here. 12A plus 4S equals 416. And I'm going to take my top equation and I'm going to go ahead and multiply the whole thing by 4 so that my S will have the same coefficient. And I'm going to write this a little neater. That got a little messy. Equals 416. So for my top equation, let's distribute 4 to everything. 4A plus 4S equals 60 times 4, which is 240. Now I have my variables lined up. I have my matching coefficients. I do need to make sure my matching coefficients are opposite signs, which they're not currently. So I'm going to pick my bottom equation and change every single sign. It doesn't matter which equation I pick, as long as the signs are different. Now let's go ahead and combine up and down like arithmetic. 12A minus 4A gives me 8A's and no more S's. And 416 minus 240 is 176. So 8A equals 176. I can divide both sides by 8 to tell me that A equals the number 22. So I know that I'm spending 22 minutes on aerobics. Okay, let's go ahead and plug that back into either equation to solve for S. I'm going to go ahead and plug it in to the top equation because it's easier. So A plus S equals 60, and A I've just discovered is the number 22. So if I subtract 22 from both sides, I can find out that S is 60 minus 22, which is 38. So I spent 38 minutes on stretching, which I'm out of room for, so I'm going to write stretch. There we go. So I found the solution to my system of equations, and now I have to take a look at the last problem, which says to sketch a graph of the system of equations. And it says be sure to label your horizontal and vertical axes and number key intercepts. So that's a clue that using intercepts is going to be the easiest way to graph these, which it absolutely is. If I try to use my slope, I have to have a really accurate grid in order to do the proper rise over run, and that's kind of obnoxious. If I'm just doing a sketch, the most important thing I need to do is label at least one number on each axis to get a good sense of scale, and that's about it. So let's go ahead and see how we can sketch these two functions as simply and efficiently as possible. So I have a plus s equals 60, and I have my other equation, 12a plus 4s is 416. What we'll notice is there's no x or y in either one of these functions, which means I don't know what my input and output are. And if we think about the context, I don't really have an input or an output. I'm not going to say, if I spend 5 minutes on aerobics, how long does that give me for stretching, or something like that. So it doesn't really matter which one is the input and which one's the output, which means I get to choose. Now on my graph, I went ahead and made aerobics my x-axis, and that was just a choice that I had for basically no reason. It doesn't really matter, but I'm going to go ahead and make this my a-axis. So my bottom of my graph here is going to stand for the time spent on aerobics. It's my a-axis, which would leave the s-axis over here, which tells me that this is going to be the time spent stretching. So I have an a-axis and an s-axis. So we're going to think of it in terms of a and s instead of x and y. So to start graphing this, I have to start finding some key intercepts, and I can find an a-intercept and an s-intercept really easily. An a-intercept happens on the a-axis, and if I'm here on the a-axis, my s value must be 0. So I'm going to take both equations and find out where they give me an a-intercept. For my top equation, I'm going to go ahead and plug in 0 for my s value. A plus 0 equals 60. And it tells me that my a-intercept is the number 60. So I'm going to go ahead and make a mark on my a-axis and call it the number 60. That's my a-intercept. Let's go ahead and do that, the s-intercept now, and just finish up this equation. So for my s-intercept, it happens here on my s-axis, and when I'm on my s-axis, my a value is 0. So I'm going to take my same equation, a plus s equals 60, but this time I'm going to plug in 0 for a and see what happens. 0 plus s equals 60, and it tells me that my s-intercept is also happening at the value 60. So a number on my s-axis, right here, we'll call it the number 60. Now I have my a-intercept and my s-intercept. I can connect these 2 points with a line, and I have now graphed my top equation about time. If I'm spending all 60 minutes on aerobics, I'm spending no time on stretching. If I spend all 60 minutes on stretching, I'm spending no time on aerobics. Now let's go ahead and do the same thing for my second equation. We're going to find the a-intercept and the s-intercept. So to find the a-intercept, again, my s value has to be 0. So 12a plus 4 times s equals 416, and I'm going to plug in the number 0 for s. That gives me 12a is 416, and that is 416 divided by 12, which is not a pretty number, and that's okay. 416 divided by 12 is 34.667. And since I'm graphing this, decimals are fine. 34.7 is just about 35. I'm going to go ahead and put it here on my a-axis, smaller than 60, just over halfway. We'll call that 34.7. There's my a-intercept. Let's go ahead and find the s-intercept. To find the s-intercept, I'm going to take the same equation and I'm going to plug in 0 for a, because again, my a value has to be 0 if I'm on the s-axis. So 12 times a plus 4s is 416. We'll plug in 0 for a. That tells me that 4s is 416, and to solve for s, I divide by 4. This is a much nicer number. S equals 104. So that's going to be on my s-axis above my 60, somewhere up here. Call that 104. There we go. And I can connect these 2 points for my next graph. There we are. Now I can see that I have an intersection here. This intersection should look like it's happening in the same places where my solution said, which was 22 for A, 38 for S. So 22 is less than this 34. So there we go. That would be my 22. And the 38 is less than my 60. So there we go. That's the 38. So it's confirming for me that the intersection is happening just about where I assumed it would be according to the solution to my system. All right, we're going to go ahead and pick up with the last couple questions for the review in the next video.